Hello all, welcome to your hot sauce lesson, background knowledge mini lesson. I'm going to cover everything you saw in the diagnostic and then give you a chance to practice some similar problems. In our first example, we see an airplane flying over the Pacific Ocean, and the table shows the number of hours and the distance in miles traveled. While the airplane, and keyword here, was flying at a constant rate. Constant rate is just going to tell us that we have unit rates going on here. There's not changing speed mid-flight. We're asking to complete the table with the missing values. I'm going to start with filling in this hours 6. I'm starting here just because for me this makes the most sense for my brain. Yours could be different, but really doesn't matter where you start. And I'm going to start with setting up a ratio of miles per hour. So we know that we started at 1,650 miles in 3 hours, and we are trying to find an equivalent ratio for 6 hours. And what you might notice is that 3, when you multiply it by 2 or double it, you get 6, and with equivalent ratios, the numerator and denominator must be scaled the same. So if our 3 is being multiplied by 2, then we can take our 1,650 and multiply that by 2 to get our numerator of 3,300 miles in 6 hours. Pop that here, 3,300. Okay, let's set up a similar ratio to find out how far we traveled in 2 hours. And to solve for this question mark of how many miles I traveled in 2 hours, I'm going to use the cross products method, meaning that if I take my cross products and I say, what is 1,650 times 2? We just got that. That is 3,300. That means that 3 times what is also equal to 3,300, because in a equivalent ratio, the cross products are equal. So we can use our knowledge of fact families here and say that an equivalent expression to this would be 3,300 divided by 3 will give us our unknown, that question mark. When we do that calculation, we end up with 1,100, which means that in 2 hours we were able to travel 1,100 miles. All right, go ahead and try your own example. All right, next up we're going to be using cross multiplication to calculate ratios. Again, looking for those equivalent ratios. And our story says we have these blueberries that are $4 per pound. So there's actually a unit rate for us. And for each question, we're explaining our reasoning. Okay, so this first question, how many pounds? I sometimes just underline their keywords there. How many pounds of blueberries can you buy for $1? So first, let's set up our rate of dollars per pound. Our first ratio is $4 per 1 pound. And we're going to set up an equivalent ratio, and this time our dollars is going to be a 1. And so we're asking ourselves, one thing you could do is you could do the scaling. So to turn 4 into 1, we know that this has to divide by 4. So that way, which means that to keep our ratio equivalent, we can take our denominator and also divide it by 4. And 1 divided by 4 is 1/4, or if you did that in a calculator, you might have gotten 0.25. But what this means is that for every $1, we can purchase 1/4 of a pound of blueberries. So for this question, we're saying now how many pounds can we buy for $13? And set up that same ratio of dollars per pound, and we can actually use our answer to part A, and we know that for $1 we can buy 1/4 of a pound, and we can scale that up. We know we want $13. So to get 1 into a 13, that is some straight multiplication. So we'll multiply it by 13. Equivalent ratios, your numerator and denominator, are scaled the same. So we can go ahead and multiply our 1/4 by 13. And we get 13/4. So what this ratio right here means is $13 can buy 13/4 of a pound of blueberries. If you put 13/4 into your calculator, that is 13 divided by 4. And what you're going to get is 3.25, which means you can buy 3 pounds and another 1/4 pound of blueberries. Go ahead and try the example. So lastly, we are given a set of axes and we are asked to plot some coordinates and make a scale. So our horizontal axis is always going to be x and your vertical is always going to be your y. And then you can have a different scale for your x and y axes. And what I usually do is I look at what the data is giving me in order to identify how I want to scale mine. Since I have fairly small numbers, I'm just going to scale by ones. That means for every hashtag, every little mark is going to mean 1. And then since my y coordinates look like they're growing by 3s, I can go ahead and scale my y-axis by 3. And now I'm going to start plotting some points. So if I have an x and a y, that is the coordinate point 4, 3. And so I can go find, again, that is always x first, y second. So I can find 4 on my x-axis, which is right here, go up to 3 on my y-axis, and plot my point right there. So that is the point where x is 4 and y is 3. Now I'm going to look for a point where x is 2 and y is 6. Again, start with your x-axis. Find 2 on your x-axis, which is right here, and then move up to 6. So this is the point 2, 6. So let me go ahead and write this one down. That is 4, 3. And lastly, we are going to look for a place where x is 5 and y is 0. So x is 5 right here, and y is 0. This is the origin, the point 0, 0. So we can actually plot our point right there on the x-axis. And that is the point 5, 0. Okay, go ahead and try some of these, and then you can move on with your pacing tracker. Thank you.